Good evening, everyone. Welcome to today's live class. I want to you have observed that I've been teaching mostly on Saturdays and Sundays. Then the essence of this teaching is for me to guide students from SS1, 2, and 3. So I'm actually covering the skill for this first term. So I'll be looking at SS1 first term, SS2 first term, and SS3 first term. So I'll be alternating them as time goes by. All right, so if you are joining us for the first time, I want you to follow us so that at the end of the term, you'll be able to achieve something reasonable for yourself. So the topic we are going to look at today is equilibrium of forces. So if you are joining us, please give it a thumbs up. Then let's proceed to equilibrium of forces. Now, if you have questions from the previous lesson we had yesterday, you can still drop your question in the comment section. And also, if you want me to teach any topic that you feel you do not understand in physics, you can also drop the topic in the comment section. Okay? All right. So today we are going to look at equilibrium of forces. Equilibrium of forces. Now, this equilibrium of forces is somehow similar to scalars and vectors, precisely vectors. So, because we're going to be looking at the resultant and equilibrant force. Previously, we did scalars and vectors in my previous video. If you do not know how to solve scalars and vectors, resultant of more than two vectors acting at a point, you can check on the video I made on my channel, okay, on scalars and vectors, and how you can resolve vectors when there are more than two vectors acting at a point. Is that okay? All right, so because when we look at that, then we realize that we can get a resultant vector, we can resolve a vector, but here we can also resolve a vector, but in another form or in another direction. And if you resolve a two vectors, we are going to get a resultant vector. Okay, and we still remember that a resultant vector is that single vector which acting alone will have the same effect and magnitude and direction as the original vectors acting together. For example, if we have two vectors f1 and we have what f2, so if this vector is going this way and this one is going this way, both of them are vectors but they are acting in the same direction. I'm going to add them together, okay, to get the resultant vector. And that resultant vector r is equals to f1 plus f2. All right, but if the two vectors f1 and f2 they are acting in opposite direction, how do we get the resultant vector? Simply by subtracting them. For example, if I say f1 is acting this way, f2 is acting this way, so how do you get the resultant vector? We're going to subtract, okay, to get the resultant vector. That is f1 minus what, f2. Or better still, the vector that has the highest number you subtract from the other one. Is that okay? All right, so I just a pre-revision of what I did earlier on scalars and vectors, because I'm going to use the knowledge to treat this equilibrium of forces. So I want you to stick to this class and put in your mind, because physics is all about concentration, and if you are being taught, you try as much as you can to see how you can solve that question by yourself. It gives you confidence that you can actually do it. Okay, so let's dive in. Okay, so we have Lily on the line. Hi. Live with Jojo. Hi. Thank you so much. Happiness, Bona. Thank you so much for joining. All right, so let's look at the resultant force. The resultant force is that single force which acting alone will have the same effect in magnitude and direction as the original vectors acting together. And this resultant force can be obtained using the parallelogram law of vectors, of which we have done it in my previous video. Okay, so I will explain it again with a diagram. The equilibriant force is that single force which will balance all the other forces taken together. It is equal in magnitude but opposite in direction to the resultant vector. What are we trying to say? That this equilibriant force is equal in magnitude to the resultant vector. So if the resultant vector, for example, is 10 Newton, it means that the equilibriant force will be 10 Newton. But the direction is acting opposite to the what? Resultant vector, right? So I'm going to use a question to explain, and also going to use a diagram to explain the two concepts. All right. So we have this diagram, F1 and F2. Okay, this is F1, this is F2. Now, for us to get the resultant of this vector, what we are going to do is to complete this diagram to form a parallelogram. Now, if you form a parallelogram, you're just going to extend this to be parallel to this. So I'm going to extend it. Okay, so this F2 is parallel to this. I will extend this to. All right. Now, if this is parallel to this becomes F1. If this is parallel to this becomes what? F2. Okay. Then we join the 2 points of intersection and call the line what? R. If you call the line R, what do we have? We have two triangles. We are going to solve with one. And this is simply explained by the parallelogram law of vectors. Okay, but what am I trying to say? I'm trying to say that this is the resultant vector acting this way. What is this equilibriant force? Equilibriant force is going this way, is E. Now, if these two vectors are acting at a point, this is the resultant force that connects these two forces together, right? This is the equilibriant force that is acting opposite to the what? To the resultant force. Okay. Now we are going to get this resultant force using cosine rule, which we state to be what? R square is equals to F1 square plus F2 square minus 2F1 F2 cos 180 minus theta. This is a cosine rule. You are using this cosine rule to get the resultant vector, right? And because it is a vector, we must solve for magnitude and also solve for the direction. Now I'm going to use sine rule for the direction, which says that what? R over sine 180 minus theta is equals to F1 over sine alpha. Now, if at the end of the day my resultant vector happens to be 10 Newton, now it means that my equilibriant force is also the same thing as what? 10 Newton. Because from the definition we said that the equilibriant force is the same in magnitude with the resultant force. So whatever thing you have as your resultant force is the same as the equilibriant force. Is that okay? But the only difference is that the resultant force is acting this way, the equilibriant force is acting this way. Is that okay? All right, so let's solve a problem to see how we can solve for equilibriant force and also its direction. at this example, two forces 10 newtons each. That means the two forces F1 and F2, they have a force of 10 newton, incline at 120 degrees to each other. Find the single force that will replace the given force system. Okay, the one that will replace the given force system is the resultant force. So that is what we are looking for in this question 1. Find the single force that will balance the given force system. The force that balances the given force system is the equilibriant force. So in this question, we are expected to get the resultant force and also solve for the equilibriant force. So I'm going to do a small sketch of the diagram so we can see how we can solve this problem. Now we have this. So this is F1, this is F2. Now we're going to draw. Okay, if this is parallel to this is F2. If this is parallel to this is F1. We join the 2 points of intersection and call the line R, which is the resultant force. Alright, so this is my R. Now bring out this portion of the triangle. So we have this, this, and this. Though I have already detailed, explained this part in my previous video. So if you still do not understand, I'm just doing it shortcut because it's just an introduction to the main topic, okay? This is not the main topic for today, but I just want to introduce it again or to refresh again so that it can help you understand what I'm going to teach after that. So, but the full explanation of these scalars and vectors is in my previous video, so you can check it out. Now, this is my R, this is F2, this is F1. What is here? Now, this is 180 minus theta, and this is alpha. Now, for us to get the result, we're going to use cosine rule. And cosine rule states that what? R square is equals to F1 square plus F2 square minus 2F1 F2 cos 180 minus theta. Now, looking at what you have, so we substitute. Now, this question said two forces, 10 newton each. It means that the first force will be 10 newton, and the second force is equally what? 10. Okay? But the angle between them is 120. So here becomes what? 120. So our F1 is 10 newton. Our F2 is what? 10 newton. You know why it is 10 newton is because the two forces have equal magnitude. They have the same thing as 10 newton. So let's substitute it and see what we have. This is my F1. I have 10 square plus 10 square, right? Then minus 2 times 10 times 10, okay? Cos 180 minus my theta, which is my angle, becomes what? 120. What am I going to do next? I'll substitute the values. R square is equals to 10 square is 100 plus 100. Then minus 2 times 10 is 20. 20 times 10 is 200. Okay? Then cos 180 minus 120 becomes 60. Alright. Now what do we have? We proceed. We say this is what? R square is equal to this plus this is what? 200 minus 200. Now, don't say 200 minus 200 because there is a multiplication sign here, which is cos what? Look at it. Cos 60. Now, let's get what is cos 60. I will just say cos what? 60. Now, I was saying something before. There is a multiplication sign connecting this 200 and cos 60. So don't just say 200 minus 200 to get 0. No, you'll be wrong. So the best way to do it is to get this cos, because some of these angles can give you a negative sign. All right, it's until you multiply, then you will not know whether you're going to add this 200 or you're going to subtract from it. Now let's proceed. R square is equals to 200 minus 200 times cos 60. Let's use our calculator to get cos 60. Cos 60 is giving me 0.5. Now, if you have 0.5, you multiply by this. R square is equal to 200 minus 0.5 times 200 we have what? 100. So r square is equal to what? 200 minus 100 is going to give me 100. So my final answer, r, I'm going to take the root of both sides, is equal to root of 100. R is equal to 10 Newton. Now we have gotten R to be 10 Newton. That is the force that will replace the given force system. Okay? That is the single force that will replace the given force system. That is my resultant, which I got to be 10 Newton. Now, because it's a vector quantity, I'm going to solve for the direction using sine rule. So let me explain the sine rule so that we can talk about the number second one, which is the single force that will balance the given force system. Please, if you are just joining us, just give it a thumbs up. Thank you so much for joining. All right, I hope you understand that now. So let's go to the next one. The next one is to use sine rule, and sine rule says that what? It says that what? R over sine 180 minus theta is equals to F1 over sine alpha. Okay? So I've gotten my R to be what? 10. 10 over sine 180. My angle is what? 120 is equals to 10 over sine what? Alpha. Now what I'm going to do is to say cross multiply. If I say cross multiply, 10 sine alpha is equals to 10 sine 180 minus 120 is going to give me what? 60. Beautiful. So what do I do next? I'm going to divide both sides by 10. Okay. Now this cancel this, right? So I have sine alpha is equals to sine what? 60. Sine alpha is equals to, what is sine 60? If I say sine 60 is equals to 0.0866, right? Then because I'm looking for the direction alpha is equals to sine inverse of 0.866, right? Now, you don't have to press it, just say shift sign, okay? In your calculator, you have shift sign. It will give you this symbol. Then you now press 0.866, okay, equals to. That will give me alpha to be 59.997 degrees. Then approximately it is what? 60 degrees. Approximately the angle is 60 degrees. We have gotten the magnitude, which is the 10 Newton, and the direction becomes what? 60 degrees. Now the first one we have got is just for this. The single force that will replace the given force system. Okay? So this is how to guess the force that will replace the given force system. Now for the one that will balance the given force system, that is the equilibriant force. And remember that it is equal in magnitude to the resultant force, but opposite in direction. Okay? So as we have gotten our resultant to be 10 Newton, it means that the equilibriant force is the same thing, that is 10 Newton. Just that it is acting in opposite direction with this one. I hope you understand. All right. So let's go to the next one. Okay, so number B part, we can say the equilibrant force is 10 Newton, right? But the direction is 60 what? Degrees, acting opposite to the resultant force. The equilibrium force is 10 Newton, but the direction is 60 degrees, acting opposite to the resultant force. So that is what I was saying, that if we have two vectors, this becomes what? My resultant force. Why this becomes what? Equilibrium force. They have the same magnitude. From that question, we have already gotten our resultant force to be 10 Newton. Now, my equilibrium force is still the same thing as what? 10 Newton. Just that the direction is moving opposite to the resultant force. So that is the concept of the resultant and equilibrium force. All right. So we're going to look at equilibrium of three forces acting at a point. right. So we're looking at equilibrium of three forces acting at a point. Okay, so let's read what we have. The three forces that keep a body in equilibrium. Listen. The three forces that keeps a body in equilibrium can be represented in magnitude and direction by the three sides of a triangle as shown below. Let me explain. The three forces that keep a body in equilibrium, that means you're looking at three forces. And how do you know what is a force or what is a vector? A vector is represented by a straight line that has arrow. This is a straight line and it has what? Arrow. So anything that has arrow becomes a vector. Now, looking at this now, this vector Q, vector P, vector E, they are acting at what? At a point. Okay? They can be represented in magnitude and direction by the three sides of a triangle as shown below. What do we mean by that? It means that these vectors Q, P, and what? E, you can use it and form a triangle. Simply put, okay? It's trying to tell us that when three vectors are acting at a point, what are we going to do? We are going to form a triangle with it. And when we form that triangle, we are going to use it to solve our other sides of the triangle, which are vectors. Okay? Now we have these three vectors, Q, P, and what? E. We are going to represent them with a side of the triangle taken in order. Right? This is going to lead us to the principle of triangle of forces. But before then, let me explain. Now, look at this vector P. It is going this direction. I will go this way. Right? This is what? P. Right? Now, where is this one going? This one is going this way. Look at Q. It's going this way. From this same point, I will go this way. This is what? Q. Right? I hope you are following. Look at E. It's going down. From this same point, I go down. This is my what? E. Have we formed a triangle? Have we formed a triangle? So this is what they mean. Anytime you see a question and you see three vectors acting at a point, Q, P, and E, what are we going to do? Just use it and form a triangle, then find the unknown. It's as simple as that. Do you understand? So that leads us to the principle of triangle of forces. So I'm going to state it and still use it to explain this. Is that okay? So we see how we can solve problems under this concept. of triangle of forces, the principle of triangle of forces states that if three forces are in equilibrium, they can be represented in magnitude and direction by the adjacent sides of a triangle taken in order. Okay? If three forces are in equilibrium, they can be represented in magnitude and direction by the adjacent sides of a triangle taken in order. So, if I sketch this again, I'm going to still explain it. I have this. This is Q. I have P. I have E. Right? These are the two forces. I can combine it to get R. Now the three forces we have are P, Q, and what? E, and they are acting at a point. So let's state it again. The principle of triangle of forces states that if three forces are in equilibrium, they can be represented in magnitude and direction. So the three forces they are talking about is Q, P, and E, and they are in equilibrium, right? They can be represented in magnitude and direction, okay? By the adjacent sides of a triangle taken in order. So the word taken in order means we are going to use them one after the other. Okay? Any direction that this P is going, that is the direction you are going to follow for P, for vector P. Any direction that Q is going, that is the direction you are going to follow for vector Q. Any direction that E is going, that is the direction you are going to follow for vector E. Right? So if that is the case, you are going to say that vector P is going this way, then I go this way. I call it what? P, right? Then Q from the same point is going this way. So from here, I go this way, right? I call it vector what? Q. Then what of E? E is going down, then I go down. Okay? Then I call it what? E. So we have formed a triangle. That is what the principle of triangle of force is telling us. Once we use these three vectors, Q, P, and E, we are going to follow them accordingly because of their direction to form a triangle. Then we now use sine rule to solve. Okay? I've already explained to us how to going to use sine rule to solve. So the first step is to arrange them according to the direction in which the vectors are arranged. Use them to form a triangle, then use sine rule to solve for any side we are asked to find. Alright, so let's see an example so that you can understand how we can use this principle of triangle of forces to solve for magnitude. Roslyn Namdi, hi, you're welcome. Thank you so much for coming. All right. Okay, so let's look at this and see how we can solve it. All right, let's go to this example. A mass of 2.0 kilogram, right? Let me include G. G is equals to 10 meters per second squared. A mass of 2.0 kilogram is supported by two cords. Now look at the mass, 2 kilogram, okay? Supported by two cords. See the first one, see the second one. Is that okay? So these are the chord, which is this and this, which makes an angle of 30 degrees and 50 degrees with the vertical. Calculate the tension in the two chords. Beautiful. Look at this question. They give us a mass of 2 kilograms, but in the diagram they have 20 newton. I want to explain to you why it is 20 newton, because weight is a force, right? And force, or if force is equal to what? Mg. Also, weight is equal to what? Mg. Now, if you are given the mass to be 2 kilograms, we multiply by G, which is 10. That is why I have 20 newton here. I hope you understand it now. So even if you are given the mass and you are working with weight and not mass, so you are going to multiply by G, acceleration due to gravity, which is also constant, 10 meters per second squared. Multiply to have what you have here. Okay, so but that is by the way. I just explained why they gave us a mass of 2 kilograms, and from the diagram they gave us what? 20 newton. They simply multiply the mass by 10 because they're acting with the weight, carrying these two cords. Now this and this. You are looking for the tension in the cord. Now this brings us to the principle of triangle of forces. This states that if three forces are acting at a point, and if they are in equilibrium, we are going to represent them in magnitude and direction by the three sides of a triangle taken in order. How do I mean? Look at this tension. This force of 20 newton is acting down. So the arrow should be going down because the weight is down, carrying the two cords, right? So what I'm going to do, I'm going to draw it. Remember, you're going to follow the direction of the diagram given to you. Now, this 20 newton force is acting down. So I'm going to draw a line, the arrow will be pointing down. That means it's acting down, right? So this is 20 Newton. Okay? Now, look at this. Look at this one. The P. Okay, let me start with Q. Q, from the same point, Q is acting this way. So from here, from the same point here, I'm going to go what? This way, following the direction of Q. So I'll go this way. Okay? That is my what? Q. Now go up here. This Q is acting at an angle of 50 degrees with the vertical. I think vertical. So I'll come here and say that this angle is here, which is 50 degrees. Why did I put it here? I am following strictly to the question given to me. Now the Q is acting at an angle 50 degrees. Now my angle 50 degrees is here, right? And that angle of 50 degrees is also acting towards the direction of the 20 Newton force. That is why it is inclined here. I hope you understand. Then the next one is the vector P. Vector P is acting this direction. Look at it. See where it's going. Okay. So from the same point, I will go this way. Okay. So from the same point, I will go this way. I will call it P. Right? And the P is also acting at an angle of 30 degrees. Now here becomes 30 degrees. Beautiful. We have formed a triangle, and that is what they want us to calculate. Now, this is just the first step to finding our tension in the two chord. What do I mean by that? Now, we have already seen that this angle acting here is 50, the angle acting here is 30. So we need this angle here, right? We can decide to call it x. And the sum of angles in a triangle is equal to 180 degrees. So I will add them together and equate them to 180. So let's go. This is 30 plus 50 plus x is equal to 180. Reason, the sum of angles in a triangle is equal to 180 degrees. So 30 plus 50 is going to give me 80. Then plus x is equal to 180, right? Now, if it is equal to 180, I will say x is equal to 180 minus 80. X is equal to 100 degrees. Now, if you have gotten that, we can now replace our x here to be what? 100 degrees. Now, this will give us a clue that we will use to solve for the two tension in the two chords, right? Now, we're looking for how to get our P and our Q. So for us to do that, we're going to use sine rule. We're going to use what? Sine rule. And I will explain what sine rule is all about and how we can apply it. All right. So proceed. Let me clean up here so that I can solve. I finished drawing, so I can use this to solve my problem. So what do we have? I'm going to use sine rule. Let me explain sine rule. Sine rule says that what? If I use this diagram to explain sine rule, this is angle A, this is angle B, this is angle C. This side that is facing angle A is called small letter A. This side that is facing angle B is called small letter B. This side that is facing angle C is called small letter C. Now, sine rule goes this way. A over sine angle A. What do I mean? The side first divided by the angle facing it. So that is A over sine angle A is equal to B over sine angle B is equal to C over sine angle C. Do we get it? The side first divided by the sine of the angle facing it, that is what? A. A over sine angle A equals to B over sine angle B equals to C over sine angle C. So that is what I mean. So if I use that concept here, you're going to get what you're looking for. Now, the side facing this one outside is 20, opposite of the angle of 100. So that is 20 over sine angle what? 100 is equals to Q over sine angle what? 30 is equals to P over sine angle what? 50. So a similar way is what I'm going to apply to solve what I'm looking for. Alright, so I put it here. So I'll go 20 over sine 100 is equal to Q over sine 30. Q over sine 30 is equal to P over sine 50. Alright, now since I'm looking for this, I'm going to equate these two together because these two are complete and I'm looking for Q and P. So I'll first equate this to make P the subject and solve for my answer. So let's go. If I say 20 over sine 100 is equal to Q over sine 30, right? What do I say? I can say cross multiply. If I say cross multiply, Q sine 100 is equal to 20 sine 30, right? What do? I divide both side by what? Sine 100, sorry. Okay, so what do I have? Sine 100 cancels sine 100. I'm left with what? Q is equal to, this is 20 sine 30, all right, divided by sine 100. Now let's go. Q is equal to 20 sine, with the help of our calculator. So we have sine 30. Of course, we know that sine 30 is 0.5 divided by sine 100, 0.9848. So let's multiply. 20 times 0.5 is equal to, divided by 0.9848. 9848. Okay, so we have 10.15 newtons. First tension, which is, so the next thing I'm going to do is to use the same method. Now, in this case, I'm going to equate this and this to get my P. Going by that, I will say 20 sine 100 is equal to P over sine 50 cross multiply. P sine 100 is equal to 20 sine 50. Then I divide both sides by what? Sine 100. 100. Okay? Then sine 100 cancels sine 100 to be left with what? P is equal to 20 sine 50 divided by what? Sine 100. So let's work it out. This is 20 times. With our calculator, let's find out what is sine 50. I have 0.766, then divided by sine 100, and we've gotten that before, to be 0.9848. So let's work it out. 20 times 0.766 is equals to, and divided by 0.9848. So that is 15.55 Newton. Now you can now see that the first step or the first approach here is for you to represent the vectors given. Once you see three vectors acting as a point, the first thing is to form a triangle, okay? And we are going to take it in order, meaning that any direction each of them is following, you're going to follow that direction. If not, you make a very big mistake. Now, you must be careful in when you are choosing this. This you are going to use sine rule. And I've already explained to you how to use sine rule. The sine first, all over the angle facing it. So this is 20. The angle facing 20 is what? Sine 100, okay? Now we say Q of the angle facing Q is what? 30. Now we say P, the angle facing P is what? 50. Do you understand? So this is how we can solve this problem on triangle of forces. So we're going to look at many more examples under this to help you understand this topic better. Okay, the question says we should do what? Calculate the tension. Okay, T. Calculate the tension T. Now, the first thing we are going to do is to look at this diagram and look at where they are going, the direction in which the vectors are going. This is 4 Newton is acting down because the weight is going down. Okay, now look at the first tension T is going this way, second tension T is going this way. Now I'm going to use these three forces to form a triangle from the principle of triangle of forces. Now let's draw it together. 4 Newton is acting down. So I'll go down. Okay, this is 4 Newton, right? Please don't mix it up. Then this is going this way. One of the tension is going this way, so I'll go this way. That is T. And this tension, T, is acting at an angle of what? 70 degrees to the vertical. So this is at an angle of 70 degrees to the vertical. Is that okay? Now, what again? This P, another tension T, is acting this way, okay? This way. So from this same point, I'm going this way to meet here. That is my tension T. They have the same magnitude. And this second tension is also acting at an angle 70 degrees with the vertical. Look at the vertical. This is this. So it's acting at an angle here, 70 what? Degrees. Right? So we have already formed a triangle. That is the first step. To use our equation to form a triangle. Right? Then the second thing we are going to do is to find this angle here, because the sum of angle in a triangle is equals to 180. So if we find this angle here, we have, okay, so let's get x. That is my unknown angle. So we solve 70 plus 70 plus x is equals to 180. The sum of angles in a triangle is equals to 180. 70 plus 70 is going to give me 140 plus x is equals to 180. Okay, so my x is equals to 180 minus 140. Now what do we have? We say 180 minus 140 to have 40 degrees. So we have gotten this x to be what? 40 degrees, right? So we are going to work with 40 degrees. The next thing we are going to do is to use sine rule. So I go using sine rule, and sine rule says that what? 4 over what? Sine 40 is equals to t over sine 70 is equals to t again over sine 70. Since they are the same, we can solve it that way. So I have 4 over sine 40 is equals to what? Is equals to t over sine 70 is equals to t over sine 70. Now, since we have the same tension, what we are going to do, we are going to equate this and this, all right, to get the value of t. So we say 4 over sine 4 over sine 40 is equals to t over sine 70, right? Now, because I'm looking for t, I will say cross multiply. T sine 40 is equals to 4 sine 70. I divide both sides by sine 40. This cancel this, right? You'll be left with t. Okay? I will say t is equals to 4 sine 70 divided by sine 40. So let's work it out with our calculator. What do we have? 4 times sine 70 is equals to 0.9396 divided by sine 40 is equals to 0.6428. So let's go. 4 times 0.9396 is equals to, then divided by 0.6428. All right, so my answer is 5.85 Newton. Okay, the answer is 5.85 Newton. And because the tension is the same, T and T, and they're inclined to the same angle, 70 degrees. So we don't need to solve for the second tension because it's going to be the same, right? And even we have different tension like T1 and T2, we are going to solve for T1 and as well as solve for T2. But because the tension is the same and they are also acting the same angle and they are also acting in vertical. Alright, so we have gotten the answer to be what? 5.85 newtons. So this is another example of how to use equilibrium of forces or principle of triangle of forces to get the resultant. Okay. All right. So we'll still solve more examples. If you have any questions so far, you can drop it in the comment section so I can attend to it. Then, if you have any topic you want me to teach you, then or to explain further so you can understand, if you're a student preparing for forthcoming JAMB, waec, and NECO, please feel free to follow these classes, and I believe by the end of the day you'll be happy you did. Okay, you can tell your friends about these classes and they will surely benefit and they will surely understand everything you are going to do. All right, so we're going to look into more examples and we're going to explain them. All right, we have this question on the board. We have to calculate the tension. I will say calculate T1 and T2. So we should calculate T1 and T2. So let's see how we are going to do that. All right, look at this diagram. Look at the diagram. The diagram goes this way. What are we going to do? We are going to form a triangle. But don't forget that this is a right angle. So when you're making a triangle, you must not forget that, okay? So now, this force of 250 Newton is acting down. So we take it down. That is 250 Newton, right? Now, this T1 is going up, acting up. So from here, I can go this way. Okay, that is T1. Now T1 makes an angle of 30 degrees with the vertical. This is the vertical. So here it becomes 30 degrees. Right? Remember that T2 and 250 made an angle of 90. So my T2 comes this way. This is T2. And the angle between T2 and 250 Newton is what? 90. We have formed our triangle. Do you understand? All right. Since we have formed our triangle, the next thing we are going to do is to find the unknown. Now, if this is 90 degrees, this is 30 degrees, what will be here? Sum of angles in a triangle is equal to 180. So this is 90 plus 30 to give me 120. I'm going to have what left? 160. Is that okay? Now I'm going to follow this. The angle facing this 250 is what? 60, okay? So 250 over sine angle 60. T1 over sine angle what? 90. Divided by T2 over sine angle what? 30. So let's go. We say 250 over sine 60 is equals to T1 over sine 90 is equals to T2 over sine 30. Now, since you're looking for T1 and T2, I'm going to use these two and equate them together to get the value of T1. So let's go. 250 over 60 is equals to T1 over 90. Now we do cross multiply. So I have T1 sine 60 is equals to 250 sine 90. Right? What do we have? We are going to divide both sides by what? Sine 60. Sine 60, right? We cancel. And I'm left with what? T1 is equals to, work it out, 250 sine 90 divided by sine 60. Okay? All right. Sine 90 is equals to what? 1. Okay? Divided by sine 60 is equals to what? 0.866. So let's divide to get what we have. Use our calculator. It said 250 times 1 is going to give us 250. Then divided by 0.866. What do we have? I have 288.68. 88 points. I can approximate 69 Newton, right? That is my T1. All right. So let's start for the second one, which is T2. I'm going to equate this and this to get the unknown. So that is 250 over sine 60 is equals to, I'm equating this to get T2. T2 over sine 30. Then I say cross multiply. T2 sine 60 is equals to 250 sine 30. And I divide both sides by sine 60. I'll cancel. So T2 is equals to 250 sine 30 divided by sine 60. So let's multiply. All right. We have this is 250 times sine 30 is 0.5 divided by sine 60 is 0.866. All right, let's multiply. Okay, 250 times 0.25, that is 125 divided by 0.866. So I'm going to have my T2 to be 144.34 Newton, right? My T2 becomes 144.34 Newton. Now look at this question now. This is actually a JAMB question. But in JAMB, you may likely going to leave your answer in terms of roots, okay? So you might not bother getting all these things because you should know a special angles like sine 60 as a science student. All right. So we have to use this to represent a triangle. That is the first step. By following the direction of the triangle. Now this 250 Newton is acting down. I'm going down, right? Then the T2 is acting this way. I'm going this way. And T2 with 250 Newton makes a right angle with each other. Then T1 is acting straight. Look at it. Straight, right? Straight to join, to form a triangle. And T1 has an angle of 30 degrees with each other. So this is 30 degrees with each other. Is that okay? So once we have done that, we are now left with what? This angle. The sum of angles in a triangle is equal to 180. And if here is 90 and here is 60, what will be here? If here is 90 and here is 30, what will be here? 60. When you add them together, you subtract from 180 to get the remaining angle, which is 60. All right. So I'm going to use sine root to solve 250 over sine 60. Okay, is equals to T1 over sine 90 is equals to T2 over sine 30. Now, because we are looking for the unknown T1 and T2, and we are not going to solve them together, what you are going to do is to solve them simultaneously, one after the other. So we equate this and this first to get my T1. Okay, by saying 250 over this equals to T1 over this, I'm going to say cross multiply and work it out and get this. Now, we are going to still equate this one with what? T2 over sine 30, which is what I have. And I'll work it out to get the answer to be 144.34 newtons. While my T1 is 288.69 newtons. Wow. It's as if this is twice of this, right? When you multiply by 2, you're going to get something like this. All right, so this is how you can solve problem on triangle of forces. We are still going to solve more examples so that you can see the various forms in which this question can come and how you'll be able to tackle it. All right. Roslyn, Namdi, I thought the arrow at T1 is to face up. Yes, thank you for that observation. Yes, it's to face up. Yes, thank you so much. That means I really joining this class. Yes, the arrow is to face up. Okay. Thank you so much, Rosie. I really appreciate that. Means you understand what you are doing, all right? The arrow here is facing what? Up. That was an oversight. Thank you so much. So if you have any question, you can drop it. Let me just look at it before I go to the next question. All right. Look at this question. Now, they gave us two forces, which is tension, T and T. They have an angle of 30 degrees with the horizontal. This 30 degrees horizontal. Okay? Now, this 20 Newton is acting down. They say we should find the value of T in the diagram. That means T is the same. We're looking for one vector. What are we going to do? We are going to sketch to form a triangle from the principle of triangle of forces. Now, if that is the case, let's go. This is acting down, okay? So I will have 20 Newton, right? Now, there's something I want you to understand in this question. We don't have horizontal. For our three vectors, this is 1, 2, and 3, right? None is acting to the horizontal, but the angle they gave us is what? 30 degrees, which is touching the horizontal, right? So what you are going to do, or what we need, is the angle touching the vertical here. Okay, this is the angle that we need. I don't know if you understand me. Our 20 Newton is acting down, which is this. Now, our t, the two t that we have, because they're the same, is acting this direction and this direction, but none of them is acting in the horizontal, but they give us an angle that's acting in the horizontal. Now, for us to get it, you're going to subtract it from 90 to get the angle that we need, because this is a right what? A right angle. So I can say that theta plus 30 is equal to what? 90, right? Because right angle is angle of 90 degrees. So theta is equal to 90 minus 30. Theta is equal to 60 degrees. So here it becomes what? 60 degrees. Do you understand? So let's resolve. Our vector t is acting up. This one is acting this way. So I'll go this way. That is t. And it has an angle of what? 60 degrees now. 60 degrees with the vertical, right? Now the second t is acting this way. We'll go this way. Okay? That is t. And it has an angle of what? 60 degrees, because the same thing is applicable to this. So the angle is what? 60 degrees. Do you understand? Alright. Now for us to be able to solve, we should remember that we have to find this angle here, x. And the sum of angles in the triangle is equal to 180 degrees, right? Okay, so that will be 60 plus 60 plus x is equals to 180. Equals to 180. The sum of angles in the triangle is equal to 180. So 60 plus 60 gives me 120 plus x is equals to 180. Then I will take this, I will have 180 minus 120, x is equals to 60. So we have gotten this x to be 60 degrees. Is that okay? Now let's dive into the solving, that is using sine rule. And sine rule says that what? 20 over, the side facing 20 is what? Sine 60 is equals to t over sine 60 is equals to t over sine 60, right? This looks so simple. So let's go. Okay, we say 20 over sine 60 is equals to t over sine 60, right? Okay. Now I can still equate it with the other one, but it's still the same. But let me equate it so that you can understand what you are doing. You don't get confused. Okay, let me have it this way. I will say 20 over sine 60. 20 over sine 60 is equals to t over sine 60 is equals to t over sine 60. Right? Now, if you have that, we have the same tension T. So what we are going to do is to equate this and get our answer. So let's equate this to by saying 20 over sine 60 is equals to t over sine 60, right? Now, I can use the short method. What's the short method? If I cancel these two, my t becomes 20. I can still say cross multiply. So let me say cross multiply so I don't get you confused. I'll say cross multiply. T sine 60 is equals to 20 sine 60, right? Then I divide both sides by what? Sine 60. Sine 60, right? Now this will cancel. I cancel this. I cancel this. I am left with what? I am left with t, right? And t is equals to 20 Newton. Now, can you imagine that this is a jam question? When a student look at it, you just shout, hey, how can this be a jam question? But it's very, very what? Simple. You now see that you don't even need calculator to solve this. Yes. You don't need calculator to solve. You already know how to use your right angle. And if you have gotten this angle to be 30, this one will be what? 60 degrees. Now use it and add it here. Okay, this is how you got it, right? Okay, that's so then the next is to sum of angles in a triangle is equals to 180. Then we got x at 60. Then we apply the principle of triangle of forces. Since the same tension is what you're looking for one because they have the same magnitude. Now you just equate them and cancel out, and the answer becomes what? 20 Newton. I hope you understand this. Alright, so this is still another form in which this question can come under the principle of triangle of forces. Alright, if you are just joining us, please give it a thumbs up. Let's solve the last question for today. Yes. Give it a thumbs up. A thumbs up. Alright, let's go. this question. It says you calculate the magnitude of T1, but we can as well solve for T1 and T2. Calculate the magnitude of T1. All right. What are we going to do? The first thing is to draw a triangle, right? From the principle of triangle of forces, right? Okay, let's go. We have the 10 Newton acting down, and there's one thing you must note. When you are drawing the one acting down, you must make reference of this. Okay? You must make reference of this to know where is you must. If the diagram says that this one is going this way, in your triangle it must go that way. Do you understand? Like for example, this is going this way, right? And if in your triangle it is going what? This. You know it's not the same. You have failed it. So you must make sure that the diagram is correct, because we are following the three sides of a triangle taking in order. So how do we do that? This is acting down. Okay, so we go down. That is 100 Newton. Right? Now, this T1 is acting horizontal, so I can go this way. Okay, that is T1. Right? Now, here comes my T2. But before I proceed, T1 and 100 Newton, they have what? A right angle here. So here is my right angle. Beautiful. Then the next thing is to join from this point and have my T2. So my T2 will start from here and go this way. Now, this is my T2. You understand? And this T2 makes an angle of 30 degrees with the vertical. So you should be mindful if the angle given to you is touching the horizontal. And in your diagram, there is no horizontal. Maybe you need to resolve it and get the angle touching the vertical. So you can subtract it from 90 if the angle between them is right angle. Now this is what? My 30 degrees, because T2 has an angle of what? 30 degrees with the vertical. So that is why the angle is touching here. If they say that T2 has an angle of 30 degrees with the horizontal, the angle will be here. Do we understand? Alright, so we are going to solve for the remaining angle here. I'll call it x. Let's solve for x. And sum of angle in the triangle is equal to 180. So we say 90 plus 30 plus x is equal to 180. This plus this is going to give me 120 plus x is equal to 180. So x is 180 minus 120. X is 60 degrees. Do you understand? Now we have gotten my x here to be what? 60 degrees. And the next thing I'm going to do now is to solve for T1 and T2 using sine rule. Okay, I will say using sine rule. T2 over sine 90 is equal to 100 Newton over sine 60 is equal to T1 over sine 30. You get it now? 100 Newton, the angle facing 100 Newton is 60. T2, the angle facing T2 is 100. T1, the angle facing T1 is what? 30. So let's go. We say 100 over sine 60 is equals to T1 over sine 30. Then it's equals to T2 over sine 60. Now, I cannot get the two unknown at the same time. What I'm going to do is to equate this and this to get my T1. So I will say 100 over sine 60 is equal to T1 over sine 30. Now let's say cross multiply. The cross multiply means that T1 sine 60 is equal to what? 100 sine 30. Let's work it out. Okay, so I have T1 sine 60 is equal to 100 sine 30. I will divide both sides by sine 60. Sine 60. So what do I have? This cancel this, I have what? T1 is equals to 100 sine 30 divided by sine 60 is equals to, this is 100 times, this is 0.5 divided by 0.866. So let's use our calculator and work it out. 100 times 0.5, that is 50 divided by 0.866. So my answer becomes 57.74 Newton. The answer becomes 57.74 Newtons. Now you have gotten my T1. Okay? Now, the same method we can still get it, use it to get our T2. By equating 100 over sine 60 is equal to this to get our T2. Alright? So we are going to solve to get our second tension. Alright, let's solve the last one. Okay. Okay. So we have 100 over sine 60 is equals to T2 over sine 90. Now that is what I have. I will now say cross multiply to get T2 sine 60 is equals to 100 sine 90. Okay. So we are going to divide both sides by Sin 60 sin 60. This cancel this. I have T2 is equals to 100 sin 90 divided by sin 60. All right, here we go. This is 100 times sin 90 is 1. Then sin 90 is 1. Sin 60 is 0.866. So let's divide. You say 100 times 1 is 1 divided by 0.866. So I will have my answer to be 115.47 newtons as my T2, right? I told you it's the same method we are going to use to get this one. Then the first step you have to put in to solve this is this. Look at the direction of the vector and see where they are going to. This is 10 Newton acting down. All right. This T1 is acting this way, right? And this is acting this way. Now you must make sure that the direction of this is going where it's supposed to go. If not, your answer will not be correct. And mind you that T1 and 100 Newton has an angle of 90 degrees. And that is this angle here. Okay? Then T2 makes an angle of 30 degrees with the vertical. And that is why the angle is touching the vertical. So this is how you can apply sine rule to solve the principle of triangle of forces. I hope you understand. All right. All right, I'll give you the last question to look at and see if you can solve it. Then it's similar to what we just did. Now, if you have this type of question, we are asked to calculate the tension T1 and T2. How do we solve it? The first step to take to solve this is to use the diagram and form a triangle from the principle of triangle of forces. That is 100 Newton acting down. I go down. Okay. That is 100 Newton. Now, from the same point, T2 is going this way. So from here, I will go this way. That is T2. And T2 makes an angle of 40 degrees with the vertical. Okay? So here is 40 degrees. Okay? Then my T1 is on the horizontal. So I'll go this, I'll extend it, then join it. Alright, so that becomes my what? My T1. Remember the direction of the arrow. The arrow is going this way, so we must follow the direction of the arrow. Then T1 and 100 Newton make an angle of what? Right angle. That becomes this. Is that okay? Now this is my T1. Then the next thing we are going to do is to solve for the unknown angle here, which is what? X. The sum of angles in a triangle is equals to 180 degrees. So let's go. And this is angle of 90. I'll say 90 plus 40 plus x is equals to 180. You know the reason? The sum of angles in a triangle is equals to 180. Okay? So 90 plus 40 is going to give me 130 plus x is equals to 180. Okay? X is equals to 180 minus 130, which will give me 50 degrees. So that means this my x here, I've gotten it to be what? 50 degrees. So what do I do next? So using the sine rule, and sine rule says that 100 over sine 50 is equals to T1 over sine 40 is equals to T2 over sine 90. All right, let's go. 100 over sine 50 is equals to T1 over sine 40 is equals to T2 over sine 90. So for us to get the unknown before we solve, so we equate these two first to get T1. So this is 100 over sine 50 is equals to T1 over sine 40. Now, you are going to say cross multiply. T1 sine 50 is equals to 100 sine 40. What you are doing is to divide both sides by sine 50. Alright? You divide both sides by sine 50. I will cancel this. So my T1 is equals to 100 sine 40 divided by sine what? 50. Now let's work it out with our calculator by saying T1 is equals to 100 times sine 40 is equals to 0.6428, okay, approximately, divided by sine 50 is equals to 0.7660. So let's multiply 100 times 0.6428 is equals to 64.28 divided by 0.7660. So let's divide 64.28 divided by 0.7660. So we have 83, we have 83.92 approximately newtons, right? So we got our T1 to be 83.92 newtons. Now, since we have gotten this, I'm going to equate this one again with T2 to get what the second tension. I hope you understand. Okay? All right. Now let's solve. So I'm going to say 100 over sine 50 is equals to T2 over sine 90. So let's say cross multiply. You say cross multiply T2 sine 50 is equals to 100 sine 90. So we divide both sides by sine 50. Okay? And this will cancel this to be left with what? T2 is equals to 100 sine 90 over sine what? 50. Alright? Now, let's work it out. T2 is equals to 100 times sine 90 is equals to 1. Let's get our calculator and find out what is sine 50. Sine 50 is 0.766. Okay? So sine 100 divided by 0.766, the answer is 130.55 Newton. The answer for the second tension T2 is 130.55 Newton. I hope you understand that. Alright, since you have gotten the first one, just want to equate this and equate this to get the second tension, which is T2. Then we do cross multiply and make it the subject, and we arrive our answer to be 130.55 Newton. Thank you so much for joining, and I really appreciate for your time. We have come to the end of this class. We are going to see you next time, forthcoming Saturday and Sunday, same time. Okay? Now, if you have any challenge, you have any topic you want me to teach you, you can just drop it on my comment section, and I'm going to do that and break it in the way that you will understand. And if you have your child or your ward that is preparing for this forthcoming waec, JAM, GCE, this forthcoming 2024, you can just, if you have any problem, I'll be doing revision on that and solving problems on that. Okay, so don't forget to subscribe to this channel for more educative videos, because it will be coming up on weekly basis, right? Okay, thank you so much for joining. I'll see you next time in my next class. Bye.